So in this example, we are going to model a portal frame. So a portal frame is a monolithic construction of beam and columns. So let it be, the file name be portal 2, then the location, then units to be metric, click create, go to structure wizard. The structure wizard, choose frame models, double click wave frame. Say let the length of the frame be 6 meters, height be 3 meters, width 0, number of bays along length 1, number of bays along height 1, number of bays along width 0, as it is a two-dimensional frame. So click. So this is the portal frame which we are going to give the member properties, support specifications and loading. So go to file, merge model with STAADPro model, click yes, click OK. So now to see the front view, click view, click front view option. Now click label settings, node numbers, node points, that what are the things which are need to be displayed in the screen. So load values, click apply, click OK. Next is properties. So let the beam be of dimension 0.6 by 0.6 by 0.23, click add, and the columns of dimension, say let the columns be 0.38 by 0.23, add, close. So select this beam property, select the beam, click assign to selected beams, click assign, click yes. So the property R1 will be assigned to beam. Now choose this property, this has to be assigned to both the columns. So select both the columns by clicking control. So select this column as well as this column. Assume the select beams is chosen, click assign, click yes. Now the property R2 is assigned to the columns. Now to view the three-dimensional view, just go to view, click 3D rendering. So this is the 3D model of the portal frame. So you can see the orientation of the column. Similarly here, the orientation of the column. If you wish the orientation in the other way, it can also be done by changing the property like here. Say for example, if you want to change, go to edit option. Say I can change the YD as 0.23 and I can change this as 0.3. If I want the orientation to be the other way, click change. Now if you see the rendered view, 3D rendered view, so you could see the other way of orientation of the column. So what we exactly need at the site, that could be incorporated by this option. You can give the dimensions accordingly. Now let me go to the original thing. So go to edit, say let the depth be 0.38 or YD be 0.38 and ZD be 0.23, click change, click close. So now again ensure view, 3D rendered view. So you could very well understand how to give different orientation of columns. So close this. Now supports, click create, click fixed support, click add. Now select the support. These supports are to be assigned to both the left support as well the right support. Assign to selected nodes, click assign, click yes. Next is loading. So click loading, click load case details, click add again, close, select this, click add, select member load. I'm going to give uniformly distributed load. So uniform pose of -40 kilonewton per meter, click add, click close. Now this load need to be assigned to the beam. So select the load, select the beam, select assign to selected beams option, click assign, click yes. So if we wish to see the load, then click view loading diagram. Okay, like this. Then analysis. So click analysis commands, go to perform analysis, print all, add, close. Then design. So click design, select concrete, select the code, IS456 code, select parameters, bring all the parameters this side, select what are the parameters which we need to give. So click FC, FI main, FI secondary, maximum main, maximum secondary, minimum main and minimum secondary. So these parameters will be sufficient. So click OK. Click define parameters. Before defining parameters, select all the members by, so you can form a rubber band window. Then you can select all the members, or just press Ctrl A to select all the members. Go to define parameters. Let characteristic compressive strength of concrete be 20 Newton per mm squared. So 20,000 kilonewton per meter squared. Click assign. FI main. Say let the Fe 500 steel be used. So 500,000. Click assign. Let Fi secondary be Fe 415. So 415,000. Click assign. Maximum main reinforcement let me restrict to 20 mm. Click assign. Maximum secondary let us restrict to 12 mm. Click assign. Maximum main or minimum main 12 to be for beams. Click assign. Minimum secondary 8. Click assign. Close. Now this alone is left over. So to do this, first select the beam. Go to commands. Click design beam, because this we are going to design as beam. Assign. Close. Now select the columns. Press Ctrl. Select the left column, right column. Click commands. Design column. Click assign. Click close. So you can see the commands, design beam, design column commands. Now select all the members. Go to commands. Take off. Because we are interested in calculating the total volume of concrete for the entire portal frame as well the total weight of reinforcement required. So click assign. Close. Now the pre-processing is completely over. Now we wish to do the analysis or processing. So click run analysis. Click save. So you should get analysis successfully completed command like this. Otherwise, if you are encountered with errors, we need to rectify and then come to this stage. Done. Then post processing. Click post processing. Click apply. Click OK. Maximize the screen. Say if you wish to see the menu diagram, click MZ. And you can minimize like scrolling the mouse. Then if you want to see the values, click annotate, go to beam results, ends, maximum, midpoint, shear ends, maximum, midpoint, click annotate, OK, close. So this is the maximum maneuved in the beam, the midspan, and maximum maneuved at the support, and maneuved in the columns. If you want to see the shear force diagram, close this. Click FY, so you can see the shear force diagram. Now if you want to see the reinforcement, as we do normally, you can go to the beam cursor, just click on the beam, double click on the beam, you can see the concrete design of the beam. Now if you want to see the design of column, just double click on the column, you can see the column reinforcement. So this completes the analysis and design of a portal frame using STAADPro Connect Edition.